guys, we're going to do some more work with implicit differentiation today. Just taking a little bit further. Let's look at this first question. It says to find the equation of the tangent line at the given point. So far, this is not any different than what we did yesterday. We're going to solve this one implicitly, just like we did yesterday. However, there is a typo, and I apologize. That's on an F. That's a 4. Sorry, I was watching Netflix and I typed it last night. I got confused. Sorry. Do what? Oh, I thought somebody asked me something. So on the left, we're going to bring our 2 to the front, times the inside, which is now to the first power, times derivative of the inner part. What is the derivative of the inside? Just y prime. Derivative of -3 is 0. On the right-hand side, to make this less confusing for myself or maybe somebody else in the room, I'm going to call that 4x minus 20. What's the derivative of that? Isn't it just 4? Yes. Now, yesterday we talked about if you wanted to get y prime by itself and then substitute your x's in and your y's in, you can. Or you could just substitute them in now. It doesn't matter. So I've got 2 times, instead of y, I'm going to put a 1 because they told us that's what y is. Leave y prime alone. 2 times 1 minus 3 is -4. Divide both sides by -4 and we get -1. So we just found the slope at that point. They want the equation. So we have y minus the y they give us equals the slope we figured out times x minus the x they give us. And that's our answer. And that's kind of what we worked on yesterday. Questions on that problem? All right, let's scooch down. What's it asking you to find? Second derivative. Second derivative, that's what this whole little thing means right here. So we got to find the first derivative. And yesterday we did this one together in our notes, so I'm going to go kind of fast on the first derivative. It's going to be 2x plus 2y y prime equals 0. I want the y prime by itself. So we subtract 2x from both sides, divide both sides by 2y, and we get -x over y for y prime. We did that yesterday. That's how you find first derivative. Second derivative. I've got a quotient here, so I'm going to have to do a quotient rule. Booker T minus Taco Bueno. So bottom times the derivative of the top. What is the derivative of the top? -1, so I'm just going to tuck that negative in front of the y. Minus top divided by derivative of the bottom. So the top would be a -x times the derivative of the bottom, which would be y prime, over the bottom squared. Now we can't leave it like this. You see where this has a y prime right here? We know what y prime is. It's -x over y. Oh, so now we're going to plug it in. So second derivative is -y plus x times -x over y squared. Now we're going to use some algebra magic, and we're going to make this look a little bit prettier. My term on the right becomes -x squared over y. I want the one on the right, or the left-hand side, to have the same denominator. So I'm going to change that to -y squared over y. So that now I have -y squared minus x squared over y divided by y squared. When dividing, don't ask why, flip the second one over and multiply. So now I have a y cubed on the bottom, and on the top, you'll see why in a second, I'm going to take out a negative.
Wait, where did that y squared go?
This one right here?
Yeah.
Went right here. Because when you're dividing fractions, you flip it and multiply. So instead of saying divided by y squared over 1, I said times 1 over y squared. So y times y squared is y cubed. On the top, I'm going to take out a negative. And here's why. That says y squared plus x squared. And at the very top, I have y squared plus x squared equals 9. So I know what y squared plus x squared equals. It equals 9. So I'm going to take that 9 and stick it right there. So that my answer is negative 9 over y cubed. Questions? So you need to be looking for things that you can replace, basically. So half the battle is getting your derivative, and then after that, it's kind of figuring out what needs to be replaced. Let's look at it. Say again? No, it will not always happen, but sometimes. Well, and I will tell you, when you're finding second derivatives, it will almost always happen, because you're going to have a y prime somewhere. You know what I'm saying? Alrighty, so we've got y squared equals x cubed, and we want second derivative. So let's find the first derivative. You find that silently on your own. And get it by itself. And make sure our answers match. Once our answers match, you see if you can find the second derivative. You're going to have to use a quotient rule. Once you do your Booker T minus Taco Bueno, the quotient rule, you can plug in 3x squared over 2y in place of the y prime. You can kind of simplify it a little bit. And we're going to need to simplify that further because you've got a fraction and a fraction. So we want to do common denominators. If I put a y on the bottom of this left term, that one becomes squared. Now, just to kind of save us a pencil lead, I'm going to fix this right now too. This says y squared equals x cubed. So I'm going to take that x cubed and plug it in for my y squared right there. So that if I have 12x to x to the fourth is what that is now, because that's x times x to the third. So this becomes 3x to the fourth over y times 1 over 4y squared. So your second derivative is 3x to the fourth over 4y cubed. And you can leave it like that. Or this is a y squared as well. You could also make that x cubed. So you could also have 3x to the fourth over 4x cubed y, which reduces to 3x over 4y. On a quiz or an assessment, we're going to be looking for, did you get the first derivative right? Did you get the second derivative right? Did you do some simplification? And then if you kind of got yourself down to sort of here-ish and maybe even a step further, then we would take it. So just kind of know that there'll be some partial credit on some of this for sure. Okay, questions? All right, backside. It says to find the points where the graph has a vertical or horizontal tangent line. We've done horizontal tangent lines, we've never done vertical ones before. Horizontal lines have what kind of slope? 0. Vertical lines have what kind of slope? Undefined, which means what?
Something divided by
It was something divided by a 0, basically. Do you guys know what this graph looks like? Before you say no, really think about it. Ocean had it. Close. It's an ellipse. It's an ellipse. And it's longer than it is skinny. And you know that because your major axis is longer than your minor axis. And major axis is with the x. So if we're talking about vertical and horizontal tangent lines, wouldn't you say that there are 2 horizontal tangent lines, and I didn't draw that very well, don't judge, and there will be 2 tangent vertical lines? So how many answers will we have total? We'll have 4. All right. We're talking about tangent lines. We know that we need to deal with the slopes, and so we're going to have to find the derivative of this. So let's do that. So we've got 50x plus 32y prime plus 200 minus 160y prime equals 0. That's sort of the straight up kind of derivative. We want to get the y primes by itself because we need to set that equal. We've got 2 different slopes we're kind of looking for here. So to get the y prime by itself, we're going to take the 50x and the 200x to the other side. This is just like what we did yesterday. Factor out y prime just like we did yesterday. Did I do something wrong? It's minus 200. Thank you. Good catch. Sorry. And we divide both sides by that binomial. I'm going to write my minus sign correctly this time. Sorry. Good catch. That's a 0. We knew we were going to wind up with a fraction because they're looking for vertical tangents, and you know that means that there's a 0 on the bottom. Now, if we're looking for a horizontal tangent, and we've got this whole fraction that we want to set equal to 0, don't we really just have to set the top equal to 0? It doesn't matter what's on the bottom. As long as the top is a 0, the whole thing's 0, right? So for our horizontal tangent, we're going to say negative 50x minus 200 equals 0. So we set the top equal to 0 because I want my slope to be 0. For the vertical tangent lines, what part needs to be 0? The bottom. So we say 32y minus 160 equals 0. Let's solve for x and let's solve for y. Get negative 4 for x and 5 for y. Okay, we done?
No.
No! We know we had 4 answers. And it says find the points. They want x's and y's. So is it negative 4 comma 5? No! X is negative 4. How do we get the y values that go with him? We plug it into the derivative or the original? Original, good, because I want to know where on this purple ellipse, it's not drawn very well, don't judge, are my 2 points. We know that there's 2 answers. So it looks kind of nasty, but it's actually going to work out pretty quickly. We've got 25, and everywhere I see an x, I'm going to put a negative 4. plus 16y squared plus 200 times negative 4 minus 160y plus 400 equals 0. 25 times 16 is what, 400? Plus 16y squared, this is going to be minus 800, minus 160y plus 400. And if you look at those constants, it's really pretty. We've got a positive 400, a positive 400, and a negative 800, so they kind of all go away. We can't plug the y in. We're trying to find the y's that go with that x value, because we're looking for the point. So we're trying to solve for y here. Now I've got a quadratic equation. So let's take a 16y actually, out of both of those. And I'm left with y minus 10. And I know you guys know how to split that apart, so you can do it in your head. So y equals what and what? 0 and 10. So for our horizontal values, for the horizontal tangents, it happens when x is negative 4 and y is 0, and when x is negative 4 and y is 10. That's what you just figured out. Negative 4, 0, negative 4, 10. Vertical happens when the y value is 5. That's what this is right here. Something comma 5 and something comma 5. So we got to plug in a 5 to the original and see what the answer is. So we have 25x squared plus 16 times 5 squared plus 200 times x minus 160 times 5 plus 400 equals 0. Bless you. So I have 25x squared plus 16 times 25. We said that before, and I believe that was 400. Bless you. Plus 200x minus 160 times 5 is 800. Plus 400 equals 0. So again, I've got a 400, and a minus 800. So that works out really nicely. I'm left with two terms that equal to 0. We're going to take 25x out of both of those. So I'm left with x plus 8. Which means, what is x? 0 and negative 8. So our vertical tangents, we know those points now. I would hate for you to do all of that work and only get half credit because you screw up the points. We started out with the y value. Make sure you put it in the y slot. You guys aren't used to doing that. You usually put your given in the x and then you solve for y. That's not what happened this time. We found our x's to be 0 and negative 8. Questions on that one? It is long. Everybody okay? Last little bit. Wants us to do two things. Differentiate with respect to x, and then with respect to t. All right, let's not freak out about the t part. Let's just leave it alone for a second. Let's just differentiate with respect to x. That's what we did yesterday. We can do that. So we have 4y, instead of y prime, I'm going to have you put the derivative of y with respect to x. I'm replacing it with this today. Yesterday we used lots of y prime and I let you do that. I said you could use either one. We're going to do this because it says with respect to x here. Minus, bless you, 12x cubed. Do I have to put anything after the x? No, because it says with respect to x. So we're good. Sorry. So we did differentiate with respect to x. We're going to call that one done. It doesn't say to solve for dy dx and like get that by itself. We're just going to leave it. That is the answer. Alrighty, so we're good with that piece. Then it says to differentiate with respect to t. So let's start at the beginning again. 2 times 2 is 4. The y is now to the first power. Now we need the derivative of the inner function. So the derivative of y with respect to t this time. So instead of dy dx, we have dy dt. Minus 3 times 4 is 12. Times x to the, now it's a 3. This time I do have to write something. I do have to go ahead and use chain rule on the x because we are differentiating with respect to t, not x. So, derivative of x would be derivative of x with respect to t, so dx dt. And it still equals 0. And that's your answer there. I don't want you to use y prime and x prime on these because number one, it gets super confusing, and number two, we're about to start some word problem type stuff, and you're going to have to know when you're looking for instantaneous velocity or as it relates to time, t, and that kind of thing, and it'll be much easier to find if you've got this. If you've got something that's like meters squared per second, you're not going to know that by seeing it the x prime. You'll know it if you see these guys. Okay, good question. Let's do the last one. Okay, first of all, with respect to x, that's what we did yesterday. So, derivative of cosine is negative sine of the inside times the derivative of this guy here, which is going to be pi times the derivative of y with respect to x. Minus 3 times, what's the derivative of sine? Cosine, leave the inner part alone initially, times the derivative of the inside is just pi, and I don't need to put dy dx or anything crazy because it said with respect to x, so we're good, equals, what's the derivative of 1? 0. You might want to rewrite this a little bit, kind of clean it up, so that it says negative pi, so there's negative, there's the pi, dy dx, times sine of pi times y minus 3 pi cosine of pi x equals 0. That's a little bit neater. Last one, with respect to t. So we start over. Derivative of cosine is negative sine. And you've got the inside, which is pi times y. Now we need the derivative of the inner function, which is going to be pi times the derivative of y with respect to t this time. So we have dy dt. Minus 3. The derivative of sine is cosine. Leave the inside alone for starters. Now I need the derivative of the inside, which is pi times the derivative of x with respect to t. So dx dt. And then rewrite it so it looks a little bit prettier. There we go. Questions?
I thought you had to do the product rule on pi vector cosine.
You would if those were two different functions, but pi is a number.
Oh, okay.
It's just like putting 3. Good question. And good catch. All right, your assignment's down there. I'll pass out the worksheet, and then you just have 3 problems out of the book. The worksheet's only 10 problems, so focus, and make sure you get them all. It's a lot of details, I know.